Hello, everyone. My name is Kevin. I'm here representing Zenrin. And as many of you may know, Zenrin is a mapping company based in Japan, and we specialize in Japanese map. So today I would like to talk about NDS database for Japan. Hello? Hello? Okay, I knew me. Okay. Yeah. Oh, okay. I would like to start by briefly introducing a little bit about our map and our process. And after, I would like to explain a few examples of how our Japan-specific contents is compiled or used in an NDS. And at the end, I would like to end with the future concept that we're working on. So starting with our maps. Yes, our map creation process can be separated into three phases: the collection phase, maintenance, and creation. So for collection, basically what we're talking about here is how we collect our data. And we mainly collect our data through two different methods. One is the walking survey, which is when our survey staff walk the streets of Japan to collect information not otherwise possible using a vehicle. And we have around 700 survey staff in Japan right now. And the second method is vehicle survey. Of course, this is the vehicle equipped with LiDAR, camera, sensor, etc., and just run Japan to collect all information they can on the road. And for maintenance, this is just some of the examples that we're doing. For accuracy enhancement, for example, we're using aerial image for position correction for the polygons of buildings and road. And we also have partnership with taxi companies in Japan to utilize their dashcam footage to update our data to increase the data freshness. And we also have systems running 24 hours a day, so we can monitor the changes. And in terms of creation, basically these are some of the statistics regarding our data. So for vehicle network in Japan, we have approximately 2 million kilometers. And for pedestrian network, there's 1.8 million kilometers. And some of the ADAS data here, one of the ADAS that we have is the building arrival point. And for those who's not familiar with this concept, this is the point on the network that is closest to the actual entrance of the building. So this is made possible because of our walking survey, where we can accurately capture the entrance of each building in Japan. And from that, we can connect that to the closest network. And then we have approximately 37 million records for that in Japan. And for traffic light, we have around 1.3 million records. And for regulation signposts, there's a 7.4 million records. And on the bottom, we see some of the things that we've been working on in recent years. One is the HD map. This is the HD map for expressways in Japan. And we have the XD map. So essentially this XD map is basically HD map, but for general roads. And it's created originally by Zenrin. We also have the Sky map. And as the name suggests, this map is used for route planning for drones. And moving on to our maps in NDS. So here I'll present a few examples of how our Japan-specific content is being compiled and used in NDS format. All this example is based on NDS Classic, but similar concept will be applied in live also. Starting with the Japan-specific expressway related content, the highway mode. So basically what the highway mode is a function that display information regarding the upcoming facilities or junction interchange on expressway in a consolidated view. And I understand that similar function is available outside of Japan. But for Japan, we usually include, for example, the actual POIs, the brand, inside the view itself. But I understand that no existing attributes or definition is available for this purpose in NDS. So what we did is we created a category for highway mode in the POI building block. And for example, for interchange and junctions, the location where the expressway branches off are set as POIs. And for the rest areas, all the POIs will be set at the same location as the rest areas. And by using this information, developers can achieve similar functions in their application. Next is also a expressway related content. This is the toll fee calculation. So this is actually an example of issues that we have not been able to solve yet. The toll system in Japan is quite complex because depending on the area, sometimes there are flat fee rate, sometimes there are distance-based rate, and then the rate changes depending on the vehicles. Also, there are special discounts for ETCU users, and the discount is actually what makes everything much more complicated because depending on the time of the day of the week, as well as the route taken, special discount is applied. And here we have actually 8 irregular cases that has not been solved yet. And what I mean by that is we're not able to calculate the correct fees for this inside NDS. So the first example is when depending on the departing interchange, the fees will vary even when the distance is the same. So usually distance-based, if it's based on distance-based, the fee should be the same, but depending on the departing interchange, some special discount is applied, and well, it ends up not being the same. And the second example is when the fee varies depending on the preceding and the following route. So a simple way to think about this is when user A uses route 1, 2, 3 consecutively, they are given a special discount. But if a user uses 1, 5, 3, the discount does not occur. And because of that, different discount applies and the fees changes. And the third example is when the detour route have the same fee as a direct route. This is an example when the government is trying to get people not crossing the city center. So for people who is taking a detour route to go to the same location, special discount is given to them, even though the distance is much longer. And since we have not been able to solve this completely in NDS, currently what we're doing is we're providing the toll fee data separately so that the developers can work on their own solution in terms of fee calculation. Next, we have the Japan-specific address content. So unlike most Western countries, Japan's address is actually not associated with any streets. Instead, is a hierarchical structure that goes from the largest geographical region to the smallest, and it consists of the following 7 levels: prefecture, municipality, district, sub-district, block, house number, and sub-number. And what makes it more complicated is that not all address have 7 levels. So depending on the areas, level may be skipped. For example, we can see here there are mainly 5 patterns from A, B, C, D, E. So pattern A is essentially an address with all levels, and pattern C is, for example, an address where the block level 5 does not exist. And pattern C is when level 4 subdistrict does not exist, so on and so forth. So how we compile this in NDS is we use dummy data and null value in the SLI. And on the right, you see 2 tables, but essentially they're the same 5 patterns. The only difference is that the upper table shows examples of address with house address, and the lower table shows example of house address without address without house number. So when the level is skipped and continues at a lower level, we simply just put in a random dummy data. And when we know that the level ends with no more value to continue, we use null for that purpose. Yes. Next, again, this is also address related. It's building a point, which I just talked about. So this is not an example of issues or any special process that we did, but this is an example of how we're able to leverage the format because of the data that we have. So from NDS Classic 2.4.6, I believe, storing address point at the lowest level of an address has become mandatory. So what we did is for address from level 5 block onwards are stored in the house number in the routing AUX tile table. And since, as I mentioned before, our data contains building route point already, we simply leverage that here in the data and use that. Next, we have the Japan-specific EV content, EV charging station data, and availability data. Now, I understand EV content is not something that is specific to Japan, but there are many attributes that we have that is not defined in NDS. So, for example, some of the attribute that we have, it's not defined in NDS is, for example, fees, regular closing day, user restrictions, special remarks, etc. So for these type of information that we have that is not defined in NDS, we simply store it as text, a text form, or as an additional attribute. But the problem here is that it makes it difficult to use when for searching or filtering. So this is definitely something we would like to discuss with NDS Consortium regarding adding this attribute in the future. Also, we recently released the real-time availability API service. So we are incorporating that into NDS. And how we're doing it is every charging station in Japan, we have a unique ID for it. We simply insert a unique ID in the NDS. So when real-time information is received, the system will know where to match that. And for Classic, this is simply stored in the volatile POI attribute. And for Live, this will be stored in the structure EV charging availability. On the right side, we have a statistic regarding the charging station in Japan as of April 2024. So there are a total of 32,000 charging stations, out of which 10,000 is rapid charging and 21,000 is normal charging. Is my time doing okay? All right. All right, lastly, I'll just talk about a future concept that we're working on, the SD-ADAS intersection polygon. This is still a concept, but we would very much love to discuss with the NDS Consortium regarding how we might achieve this in NDS format. Now, essentially what this is a combination of our next generation SD map and our XD map. So I'd like to first talk about that separately. For our next generation SD map, basically what we're doing is that we are maintaining all the geographical features that constitute a road as polygons. For example, road polygons, intersection polygons, sidewalk polygons. And from that, of course, with detailed attributes. And from that, we're able to automatically generate the road network necessary for our SD map. And that's what we refer to as our mobility-based network. For our XD map, the high precision XD map, similar concept applies here. We also maintained high precision dedicated road and intersection polygons. And based on that, we create link network. Additionally, we also maintain other high precision attributes such as lane marking, road paint, traffic signal signs, etc. And by combining the SD, our next generation SD map and our XD map is what we're working on right now, and we refer to it as the SD-ADAS intersection polygon. So essentially, what this is that we use a combination of both to try to achieve a safer driving experience in intersection. And starting with the polygon itself, like why polygon? So previously, it was not possible to precisely determine whether or not a vehicle has entered the intersection. But by using a clear defined areas, we can now determine that. And once we know that the user has entered the intersection, safety features in general or a safety feature dedicated to intersection can be activated to provide a better driving experience. And some of you may be wondering why intersection. Well, according to statistic, over 50% of the accidents occurred in an intersection. So we just thought it would be a great place to start to make driving safer. And in terms of XD map, how XD map plays into all this is one of the example or concept that we're thinking is once the user enters the intersection, we can switch from a SD network to a high precision XD network to allow a better lane guidance. So yes, that's the concept in work right now, but in the future, we would definitely like to discuss with NDS Consortium regarding necessity for the format and specification that will allow the switching of network, for example, in the intersection. And that is the end of the presentation. Thank you.
Thank you, Kevin.